Hello everyone, welcome to my class. Today we are going to discuss chapter 3 part 4, solution of circuit. Just recap a little bit our previous lesson. So previously we discussed the resistor, inductor and capacitor, their uses and the formula they follow. Like resistor, they use Ohm's law, V equals IR, capacitor Q equals CV, and the relation between VIR or QCV, this also can be written like that, but for inductor, V equals negative L VI dt. Okay. Also, we have seen the circuits, the simple circuits for resistor like this, for inductor and for capacitor. Their difference is resistive circuit and inductive circuit are similar. Okay. They consume the electric current, whereas capacitor circuit is reverse in nature. They store the charges. Now, the series and parallel, there are two orientation for the circuits. So these are the series circuits for resistors. There are three resistors connected back to back in a row. Whereas in parallel, they are connected parallelly by two nodes or 2 points common. Okay, this is same for capacitor and inductor also. So these are the series, these are the parallel. Now, what is the equivalent of total resistance for a series circuit and for a parallel circuit? So for resistive circuit and inductive circuit, they are similar. For series, R equals R1 plus R2 if there are two resistors. And for inductor, L equals L1 plus 2. Whereas in parallel, they are 1 by R. This is the total resistance equals 1 by R1 plus 1 by R2. For inductance is also 1 by L equals 1 by L1 plus 1 by L2. Whereas for capacitor in series, their total capacitance value is, the relation is 1 by C equals 1 by C1 plus 1 by C2. Whereas in parallel, they are C equals C1 plus C2, direct addition. And they follow these formulas. Okay. Now, most used formula is Ohm's law. So V equals R into I. Okay. Or we can express in terms of different forms. Like this. And the other one is power. Power consumed in a full circuit or complete circuit through current flow. So P equals V into I. There are two other forms to express it depending on the Ohm's law. Now, in details, the circuit solution means solving the values of current, voltage, or resistance in a circuit, or getting the unknown values. How we can get? Before that, we need to know what are the behavior of a series circuit and parallel circuit. So for series, there is only one path from a starting to end for a complete circuit. So the voltage source supplying V volt to the circuit and the current is I. The current only follow the path. So since there is only one path, current flow is same for throughout the circuit. Whereas depending on the value of the resistors, the voltage will be divided like A and B. The voltage drop, okay, or change is V1. For B and C, for resistor R2 is V2 and so on, V3, V4. So total voltage V equals should be V1 plus V2 plus V3 plus V. So This, the division of voltage, is known as voltage division law. Now, for a parallel circuit, let's see how the behavior of voltage and current. Parallel circuit, it depends on 2 points, and the resistors are connected through these 2 points like A and E. So all the resistors R1, R2, R3 and R4, they are connected in parallel. So since voltage difference depends on 2 points, because voltage is the potential difference, so voltage will be same throughout the circuit for all paths, R1, R2, R3 and R4, all paths. Whereas the current I, current depends on the path, so it will be divided at this point A. So for resistor I1, and then for resistor R2 is I2, and so on. Depending on the value of the resistors, it will be divided and it will be combined here at the point E to become the same current as circuit current I. So I equals I1 plus I2 plus I3 plus I. So here currents are divided according to current division law while voltage is same for parallel. Okay, again recap. In circuit series circuit, current is same throughout the circuit, whereas voltage is divided among the resistors according to voltage division law. Whereas in parallel circuit, voltage is same among all paths, whereas current is divided according to current division law based on the value of the resistance. So what is current divider rule? CDR, that for a parallel circuit, current is divided. So I1 equals R2 divided by R1 plus R2 multiplied by IS. What is IS? Is the I, source current. And I2 equals R1 divided by R1 plus R2 into IS. Whereas for series circuit, for the same resistors, voltage is changed or divided. So V1 equals R1 divided by R1 plus R2 into Vs. Vs is the source voltage, and V2 equals R2 divided by R1 plus R2 into Vs. So we are, as solving the circuit, we are going to find the unknown values. Either it can be current or voltage or resistor. Let's go to the example. First, the simple one, what we have done before. Okay, this is 3 resistors connected in a series. What is the total resistive value? Because they are in series, so our equation is straightforward. Total resistance or equivalent resistance are equal. EQ equals just straightforward summation 2 plus 8 plus 6. It is 16 ohm. Whereas in parallel orientation, the 3 resistors with resistance 2 ohm, 4 ohm and 6 ohm. So the equivalent resistance 1 by R equivalent equals 1 by 2 plus 1 by 4 plus 1 by 6. We calculate this one, the value will be 12. R equivalent equals 12 divided by 11, means 1.1 ohm. Here to mention that when they are connected in series, the resistive value will be more. Whereas when they are connected in parallel, the resistance or equivalent resistance will be much lower than the series orientation. Okay. Now, let us see one complete example with a parallel circuit. So here, 2 resistors are R1 and R2. R1 is 20 ohm, R2 is 60 ohm given, and with a power source 120 volt. So I've shown here, current in the circuit coming here is divided in terms of different parts, 2 parts. So let us current here I1, here is I2. Question is asking, find the voltage and current in each resistors. Okay, that is for each path. And find the total resistance and the total current for the circuit as a whole. Now, we know for a parallel circuit, the voltage is same for all paths. So V equals V1. If we consider here is V1 for path 1 and for path 2 is V2, they are all equal to 120 volts. We know the Ohm's law, V equals IR. From there, I equals V divided by R. So we know the R1 value, we know the V. So we can find out the I1 for the path R1. So I1 equals V1 by R1, 120 by 26 ampere. Whereas I2 equals V2 by R2, 120 by 62 ampere. Here, one thing we can clearly understand that the resistance value is more, current flow will be less. Okay, here is 60 ohm, so only 2 ampere. Here is 20 ohm, so only 6 ampere. Okay, so that is one thing, that current flow depends on the value of the resistor. Now, second question, find the total resistance and total current. Let us go for total current first. Total current I equals, it will be, here is I1, here is I2 coming back. So I1 plus I2, we know I1, we know I2. So just add up, 88 amperes. Now, the total resistance, there are two ways to find out. One is using this, R equals V divided by I. So we know V 120, we know I, total current 8, so 15 ohm. Another way, just use the law of equivalent resistance or total resistance. 1 over R equals 1 over R1 plus 1 over R2. Means 1 over 20 plus 1 over 60, and you will get the same value. You can try. Now, another example, little bit more details. One series circuit is given in this picture with 3 resistors, R1, R2, and R3. The voltage source supplying 10 volt to the circuit. Value of R1, R2, and R3 given 8 ohm, and 4 ohm. Question is asking us, find the current flow through the circuit and each resistor. Through the circuit means I, and then each resistor, I1, I2, I3, if the current for resistor R1, R2, and R3 we consider. Okay, and then the voltage drops and power dissipated for each resistor and for the circuit. Okay, so let us go for the what is the total resistance. Because 3 resistor given, we can straightforward add up total resistance value, or RT, or R equals 8 plus 8 plus 4, 20 ohm. Now, we know the total resistance, we know the value of V. So we can use the Ohm's law, V equals IR, to find the current flow in the circuit. So I equals V by R. Okay, V is 10, R is 20, 0.5 ampere. And also we know for a series circuit, the current will be same throughout the path. So I1 also 0.5, I2 also 0.5, I3 also 0.5. Okay, it's the same as I. Okay, so the question number 1 is done because for each resistor the current is same with the circuit current. Now let us go for 2, the voltage drops. Okay, first resistor R1, let us consider the voltage drop V1. So V will be I R1. I1 R1, I is same as I1 is same as I, so I R1. Now I we know 0.5. R1 is 8 ohm, so it will be 4 volt. Similarly, V2, because it's the same current and value of the resistance also the same, is 4 volt. And V3, the resistive value is 4, so 4 into 0.5 is 2 volt. So how much the voltage drops, we can find out there. One thing we can make it clear that based on the value of the resistors, if the resistive value is more, voltage drop is more, means reducing the voltage towards the end. Okay, R3 is 4, right? So here 2 volt, but here is 884 volt. So more resistance, more voltage drop, or more voltage will be consumed, current will be consumed. Okay, so what is the equivalent power? We know power P equals I into V. So I is same throughout the circuit, which is 0.5, and V is 4 volt. So for the resistor 1, P1 is 2 watt. For resistor 2, P2 is 2 watt. For resistor 3, P3 is 2 into 0.5 means 1 watt. Now let us see what is the total power consumed by the circuit. So P, we know total power equals P1 plus P2 plus P3. Okay. So again, by the formula, power P equals I into V. I 0.5, V is 10. So is 5 watt. Now these three we can add. 2 plus 2 plus 1 is 5. Is the same. Is the same. Okay. Here is 5 watt, and if we add, this is the same 5 watt. Now, what is the total voltage? Voltage is 4 plus 4 plus 2. Okay, means 10. We can see the total source voltage is 10 volt, right? Is the same. Now, one more thing so we want to know from here, how much the energy consumed, because it depends on the how much power is used, right? So how much energy is consumed for this circuit if they are light bulb. So for example, light bulb for a month. So we can calculate this one. The energy total consumed energy E equals power consumed multiplication the time duration or time. So the power consumed here we already get 5 watt. Multiplication time T. T is 1 month 30 days, 1 day 24 hours. So if we multiply 3600 watt hour. Now let us see for the same circuit but in parallel connection, how is the behavior? Okay, the same circuit, V is 10 volt, battery, total current I, here is 3 path, I1 for R1, I2 for R2, I3 for R3. 2 common points, so voltage difference will be the same. And the R1 is 8 ohm, R2 is 8 ohm, R3 is 4 ohm. Total resistance now 1 by R equals 1 by 8 plus 1 by 8 plus 1 by 4. Okay, by the formula. If we calculate this one, it will be 1 by 2, means 0.5. So what is R? R equals 2 ohm. If we invert. So R equals 2 ohm. From here, you can find out what is the total current, because we can use the Ohm's law, V equals IR. So I equals V divided by R. Because we know V is 10. And we know R is 2. So 5 ampere. Here we can see in parallel, total resistance is 2 ohm. But just now in series, it was total resistance was 20 ohm. Okay, as usual. So the total current flowing through the circuit is 5 ampere, whereas for series circuit it was 0.5 ampere. Okay. Now, since the voltage is same for each resistor, is the 10 volt. So what is the current for each? I is equal to V by R. So for the first path, I1 equals V divided by R1. So 10 by 8, 1.25 ampere. Similarly, for path 2, for resistor R2, 10 by 8 is the same, 1.28 ampere. And for the 3, it's 10 by 4, because this one is 4. So 2.5 ampere. Okay. So resistance is more, current flow is less. Resistance is less, current flow more. Again the same. So what is the power consumed by each resistor or power dissipated? So first one, P1 equals I1V. 1.25 into V is 10. So 12.5 watt. For the second one will be the same because the value of the resistance is same, current also same. For the third one, it will be here 2.5 I3 into V. So I3 is 2.5, V is 10, so 25. So let us see what is the total power. Total power will be P1 plus P2 plus P3. And it will be same as the power consumed by the circuit. So what is total power? From the Ohm's law, also we can see, this is the verification. If we add these three, it will be 50 watt. So also we can use Ohm's law to find the total power consumed. P equals IV. We know I is 5 ampere, V is 10, 50 watt. They are same. Okay. Now, what is the total current? Total current, let us check. Total current I equals I1 plus I2 plus I3. So if we add up these three, it will be 5 ampere. We know total current is 5 ampere. It's the same. Again, let us calculate the total energy consumed for a month, like series circuit. So equals PT. In this case, power is 50 watt. So 50 multiplication 24 hours a day, 30 days a month. So 36,000 watt hour. So we can see for parallel circuit, if they are light bulb, the consumption of the energy is much more than the series circuit. Okay, so this is the trade-off. Here, the light actually intensity will be same or equal for each bulb if we consider they are bulb with the, and parallelly we can use all. There is no disturbance if one bulb is cut out, okay, or burnt. But for series circuit, if one is burnt, whole circuit will not work. But the consumption of the energy is much less. So electric bill will be less, but the intensity of the light will be bit dimmer. Okay, not with the same intensity. So that's the trade-off. In household, we use the parallel circuits so that we can do all the work, means based on electric current consumption, like light bulb. We can watch TV, we can use our microwave oven all together parallelly without any disturbance. Whereas series circuit we use for decoration light, all will give the light together but in a dimmer, so there is no problem. Like Christmas light, okay, our Eid decoration light, like this. So let us see some other example, but I put here like this so that you can try yourself. Like this one, series circuit, there are three resistors, R1, R2, and R3. The value of the resistors are given to R1 2, R2 is 4 ohm, R3 is 6 ohm. The voltage source giving 10 volt, 10 volt supply. Okay. Find the value of here for R1 is V1, V2, V3. For I is I1, I2, and I3. But one thing, this is series circuit, all I is same. So you can calculate the I value equals V divided by R. So get the total R first. V is given 10 volt. We can find out the values. Similarly, the another one, the same. They are in parallel, R1, R2, R3, 2, 3, and 6. Okay, here 2, 4, and 6. Here 2, 3, and 6. And total voltage is given 12 volt. So you can calculate here V1, V2, V3. Here is I1, I2, I3. Here V1, V2, V3 all will be same as V, but this will be different, okay, based on the value of the resistance. Just now we have seen, you can calculate. Okay. Now There is one more. Here, one circuit is given. The battery or voltage source is supplying 60 volt, okay, voltage to the circuit, and 3 resistance, R1 value is 17 ohm, R2 12, and R3 11. Okay, so solve this circuit for its total resistance, total current, total voltage drop at each resistor. Voltage drop, because total voltage we know, voltage drop at each resistor. Also compare the efficiency in terms of energy consumption for a month and advantage of this circuit, where it can be applicable. So we know total resistance, just add up these 3. I will be same, I1, I2, I3, I total will be same, but the voltage will be divided. I put here means the voltage is divided. So total voltage equals voltage drop in V1, V2, and V3. Okay, so you can find out total voltage is 60 volt given, and you can check, calculate all these things. Similarly, this one for parallel. So for parallel, the same circuit with the same resistance or resistive values, but connected in parallel. These 3 are together in one node, one point. Here also these 3 are together in one node, as we mentioned before. So the total resistance 1 by RT equals 1 by R1 plus 1 by R2 plus 1 by R3. Voltage is same for each parallel path, and current is divided. So total current IT will be I1 for path 1, I2 for path 2, I3 for path 3. It's like that. So total resistance for this 1 by RT equals 1 by 17, 1 by 12, 1 by 11. So this one is actually 1 by RT is 0.233. Okay, so we can convert and get the value. Voltage is same, so I put here same. Use our Ohm's law of V equals IR. We can get all the values of RT, IT, I1, I2, and I3. Okay, and also the total power and energy consumption. You can find it out. That's all for circuits. Okay, stay tuned. Thanks for watching. See you for the next for our next lesson.